Good afternoon, everyone. Thank you guys for staying around for this talk, and you almost made it. It's almost networking time. So for the last session, I just want to tell you about some of the open source tools that I use in my day-to-day work using, working with serverless and AWS Lambda and so on. I want to start by just talking about probably the most important category of tools that you should be using today, which are the deployment frameworks that you use to deploy your serverless applications. And of course, you're going to have lots of choices here. You've got your server framework, you've got AWS SAM, CDK, Cloudera, Terraform, and so on and so forth. And we went through a whole period where pretty much every other month there's going to be a new framework that gets announced. And I spent some time playing around with them, and I'd like to think of them in two axes in terms of how opinionated the framework is versus also how customizable they are as well. The two are not mutually exclusive. If you take the server framework, for example, it's quite opinionated in terms of how you should structure your application, but it also gives you a way out if you don't agree with the decisions the framework has made through plugins. The most important thing, though, I think, is that you shouldn't be writing and rolling out your own deployment framework. And this is precisely the kind of undifferentiated heavy lifting that we try to get away from by moving to serverless and get all the agility and productivity back into how we work. So personally, I'm a big fan of the serverless framework. I use it for pretty much most of my projects, but I have also done some work with other frameworks as well, such as SAM. The main thing I would say that server framework has over SAM is that it has got a rich ecosystem of plugins. And the problem with SAM is that I don't have a way to disagree with the framework. In fact, I was working with a client a while back, and we were trying to use the capability to use AWS IAM as authentication for API Gateway from SAM. They just announced the feature, and we used it. However, the way it was implemented was that your caller have to have the IAM permission to both the API Gateway endpoints, but also the Lambda function behind it, which of course is completely wrong because that just breaks your abstraction layer altogether. So the only way I found to get around this limitation was by writing a CloudFormation macro that gets deployed to AWS account so that when SAM says, please deploy my stack, I have to modify a tiny bit in the CloudFormation stack that SAM is trying to deploy in order to get around this, what seemed to be a very simple mistake, or this is a simple decision that I don't agree with. And another very popular framework I find is the Terraform, which I think is great for provisioning infrastructure, things like VPCs, networking, things like that. I think it's perfect tool for that. However, I also find it to be terribly, terribly unproductive when it comes to a lot of things that I do day to day in terms of writing Lambda functions, deploying them, shipping them with API Gateway, and so on. A perfect illustration of how this compares to serverless framework is that on the left, that's how what I wanted to write to create a new API endpoint and hook it up to a Lambda function. On the right is what I got to write for Terraform, which is basically a small, I guess, one-page essay to describe a very simple thing that I can express in the serverless framework. And often find the companies will use both side by side, whereby a lot of the core infrastructure, share components, if you see and so on, they're provisioned with Terraform. But for the applications, which is mostly Lambda functions, API Gateway, and so on, they will use something like serverless framework. But before you just jump on and go do everything with serverless framework or other frameworks like that, which give you a nice abstraction to work from, there is a word of warning, and I have to say that's probably the best warning sign you ever have, that it's really beneficial for you as well as for your team if you understand what the tools that you're working on is doing for you behind the scenes. And I think there's a lot of value for you to just learn CloudFormation really well. If you can, try to provision everything yourself at least once or twice to understand what is involved, what are all the different things that the tool is automating for you, all the different resources that CloudFormation is provisioning for you so that you understand what the tool is doing before you try and go and automate without understanding what the tool is doing so that whenever something happens, you just lose hours and hours trying to figure out what's actually going on because at that moment in time, you have no mental model of how things actually fit together. Only what is exposed to you by the abstractions that the tools give you. So as much as I love serverless framework, I think it's a mistake to only use serverless framework and never learn CloudFormation and how it transforms what you write in your serverless YAML into CloudFormation. That said, once you understood the underlying mechanics of CloudFormation, try and find tools that allow you to be very productive. And that's my problem with things like Terraform, whereby Sure, I understand how things work now, but I don't really have an easy way to reach that level of abstraction that allows me to be very productive. I don't want to have to worry about all the nitty-gritty details all the time, even if I understand them. Another thing I think you should be aware of is what I would call vanity features. So features that makes you feel good, that looks really fun to use, and features that appeals to your inner vanity and your inner programmer. If you've never heard of the term programmer, it's basically your dude that goes home and says, "Yay, I'm a programmer." And the real programmers write Java code. Python, that's not real code. Neither is JavaScript, but whatnot, which is so macho and so stupid. But nowadays, I'm hearing this other thing more and more now that YAML is not real code. The real programmers write real code. And that all your stuff, I actually got this as a comment to one of my blog posts, that serverless is not as good as, say, CDK or Pulumi because it's using YAML, and YAML is not real code. Code doesn't imply general purpose language. Is SQL code? Absolutely. Is YAML code? Well, why not? It sure ain't a natural language. If I start talking to my mother in YAML, she's not going to understand what the hell I'm saying, right? It's a system of symbols and the syntax that allows you to describe something else within that system, which by the definition of code in the Oxford Dictionary is what code is. And putting aside the argument of whether or not YAML or JSON should be considered as code, the more important question we should be asking ourselves is, what do we look for? What should we be looking for from infrastructure as code? From the tools that we use that give us the infrastructure as code, I think having syntactic correctness, implying semantic correctness, and having only one way to interpret things is a pretty good starting point. It removes a lot of arbitrary confusion just because people understand whatever you've written differently. Having a way to describe what it is that you're looking for, the end state you're looking for concisely also helps remove those confusion as well. And in a large organization where you've got teams that want to use Java, some teams want to use .NET, some want to use Python and JavaScript, it's also very important to have tools that everybody can understand. Would it make sense for you to have every team writing the infrastructure in different language, the language that they prefer to work with, and no one can read the infrastructure code that's the other team's provisioning? Probably not, right? I think, especially for large enterprises, having this ability to have infrastructure as code that is interoperable and be understood by every single team is necessary, is a must. And my biggest fear for tools such as CDK and Pulumi that allows you to write infrastructure using general purpose language is nicely summarized in one sentence by Forrest Brazil, that in my experience, these imperative tools, which lets you define cloud infrastructure in general-purpose programming language, opens themselves up to arbitrary complexity based on the whims of their users. And I think that's the thing that worries me the most about these kind of tools propagating and become widely adopted by everybody, where you can just write the same thing in 5 different ways, and that becomes confusing for people that are reading it, because now I've got to interpret in my head, build a mental model of the end state you're looking for, as opposed to just describing what the end state it is that you're looking for. And things like this arbitrary complexity just flies in the face of everything we should be looking for from our infrastructure as code tooling. But you might say, but it lets me provision cloud resources using my favorite language. And for that, I think Ben Cahill has got a perfect answer. Grow up. I mean, I get that being able to use your favorite language to do all these things keeps you inside your comfort zone, but your comfort zone, how you feel about the tools that you're using, is not the point. It's not about what's the easiest and most fun for you. It's about what makes you the most productive and best for your organization. Now, I don't want to spend 20 minutes talking about this, which I definitely can, but I recommend you to go check out Ben's talk, who's basically done a really good job explaining why YAML is still the worst tool, but much better than everything else you have when it comes to infrastructure as code. Personally, I think CDK and Pulumi there's nothing wrong with them, but I definitely question some of the motivations for choosing these tools over others. And if you're picking a deployment framework that lets you write JavaScript for the pure purpose of writing JavaScript, then I think it's almost like picking a car because it's got red leather seats, as opposed to asking questions that's more important, such as, does it have seatbelts? Does it have airbags? Things that's going to save your life when things go wrong. Again, vanity features that makes you feel good, but maybe not really necessarily good for you. So I guess, enraged half the room, maybe. So now that I've done that, let's give a name to the face that you want to punch now. So my name is Ian. I've been working with AWS for over 10 years now. I'm an AWS Serverless hero. I have done quite a few things with Serverless, and this is one of the high-level architecture for a startup that we used to work before, where we moved the social network to run pretty much entirely on Serverless. And nowadays, I spend half of my time working with Lumigo as developer advocate. And Lumigo is a troubleshooting platform for serverless applications. And the other half of my time, I spend working with clients as an independent consultant, helping them adopt serverless technologies successfully. And in my spare time, I publish video courses, write books, and so on. So I want to start with just some really useful plugins that I use with the serverless framework all the time. And if you want to find a really nice list of some of the most popular plugins, you can just go to this URL here, serverless.com/plugins. And the one that I use quite often, pretty much every single project, is the serverless IAM roles per function, which allows you to define IAM roles for every single function. And this is something that SAM allows you to do out of the box, but with the server framework, the default behavior is that you will provision one IAM role for all your function, which of course defies the principle of least privilege, where you want to create one IAM role per function and give that function just the permission it needs to do its job and nothing more. And then there's also serverless Webpack as well. If you're using JavaScript then to write your functions or TypeScript, then you probably should be using this already. This allows you to really nicely pack and bundle your deployment artifacts so you can have much smaller artifacts that you upload. But also, importantly as well, it helps you cut down your cold start time. And this is because I did some experiments a little while back to measure the performance impact that Webpack has, which are all the yellow bars you see here. And when it comes to cold start, a lot of it is determined by how much dependencies you have. And what a lot of time is spent during that initialization is just doing runtime resolution of dependencies. So when you say require AWS DK, the runtime has figured out, well, what do you actually mean? I've got to look in your node modules folder, and then I'm going to look at the /whatever path folder for AWS. And then I also have to look at the actual execution environment itself to find out where the dependency actually lives. And then you've got to do this iteratively for every single nested dependency as well. So when you use Webpack and bundle everything into one file and minimize it, then you remove all of that runtime overhead, which is why you're able to save quite a bit of time when it comes to optimizing your cold start, just doing something very simple by using Webpack. And then there's also serverless offline. This one I don't actually use very much myself. It allows you to start a version of API Gateway locally, which is quite useful if you want to debug locally. Where I do find it useful is to be able to say, OK, I'm doing some server-side rendering. As much as I can just run serverless invoke local to see the response, I can't figure out what that actually looks like on a browser. So being able to run a local instance of the API Gateway allows me to point a browser to actually see what my server-side rendering is actually doing. And then there's also a serverless if you do a lot of API Gateway stuff and you want to use the custom domain names, there's also this one called a Serverless Domain Manager. So what this plugin allows you to do is to say, OK, I want to create a custom domain for my API Gateway instance, and I want to also register the Route 53 record and all of that as well. So I can configure everything inside my serverless YAML and have everything being provisioned as part of the deployment cycle, rather than have separate steps to then create the API, provision the custom domain name, register the Route 53 record, and all of that. And this one is one of mine. We've been working with Horika-san in Japan, server step functions. So if you're doing a lot of step functions, building workflows with Lambda and step functions, then this is a really good plugin for you, which allows you to firstly just write your step function definition in YAML inside your serverless YAML. But also we have a lot of value-add features, things like being able to easily create trigger that can invoke your step function's execution from API Gateway using CloudWatch events or Event Bridge, as well as using a schedule as well to run like a step function execution as a cron job, for example. Also, I'm very big on the operational side of things, so I put in support for being able to do alarming, configure alarms out of the box, but also notifications through Event Bridge and CloudWatch events, which basically allows me to then automate a lot of the error handling. So, for example, my execution just failed. I want those to be captured in, say, a DLQ. Then I can use that to capture the result and then put it out and put it into, including the error as well, put it into a DLQ, or I can say, please invoke this Lambda function to do some automated remediation actions. Also, step functions, there's a syntax to it, which is quite confusing to newcomers. There's also support for validation before you deploy, so you don't have to deploy and then run to find out, oh, I've got invalid syntax. We also support the new express workflows as well, which is a far cheaper variant of normal step functions, where you pay for now uptime and the duration, as opposed to before, where you pay for state transitions. And step function is one of the most expensive services you'll find on AWS. So express workflows addresses a lot of this problem with cost. Another interesting thing when you're working with step functions is that when you deploy an update to the step function, existing executions will continue to run as they were. They're immutable, but the functions that they call individual steps, those can change as part of a deployment. So in order to have a safe deployment whereby you can have real blue-green, whereby when I deploy some changes and I'm updating the code as well as the state machine definition, I don't want the existing stuff to break when they after finish waiting for like 5 minutes or whatever. So this is what you can do with the blue-green deployment support that we have in the framework, so in the plugin. And the last plugin I want to talk about is Serverless Finch. If you do any sort of static site hosting on S3, for example, this is quite a handy plugin which allows you to create a serverless project, put all of your statically generated sites into a folder, and then you can use Serverless Deploy to deploy your static site and configure all the right things. And so you can have a static hosted site just deploy like this very easily. So those are the plugins, our serverless framework plugins I wanted to talk about. And now I want to talk about some of the nice, two really useful CLIs I use every day. The first one is came from a company based in the Netherlands called MoneyU, where they have lots of AWS accounts, and they will run into issues in terms of how do we maintain and upkeep all the different accounts within our AWS organization. So instead, where there's a lot of the things are great, but you have to click in the console for everything. So they built a tool that essentially is CloudFormation as an extension to CloudFormation that allows you to manage the entire AWS organization using infrastructure as code, using YAML definitions. That's very similar to what you find with CloudFormation. So in this case, I can add the new AWS account, I can create a new account, create a new organization unit, add the account to the organization unit, configure the service control policies, hook up all the CloudTrail configuration and all the security guard configuration, all of that, all done in code. And also, if I've got existing organization, I want to capture and use this tool to help me manage going forward, I can also have one command I can run to extract the current configurations and turn them into a template, so I can then source control that and use that to manage my organization going forward. You can also take a CloudFormation template and apply that to multiple accounts, multiple regions, or with just one command. And similarly, when you have lots of different resources that are configured in different accounts and want to cross-reference them, they also support something very similar to what you find with pseudo functions in CloudFormation, your ref, get attributes, sub, and so on. And this works across multiple accounts and multiple regions. If you have ever had to do much with organizations, I can't tell you how powerful this is, how much work this is going to save people. I've spent so much time just dealing with the scripting, essentially scripting as something similar like this, but really, really badly. And of course, we want everyone to use infrastructure as code and also automate the deployment process. So they also have a command that allows you to just bootstrap a code build and code pipeline, CI/CD pipeline for your organization, so that going forward, whenever you want to make a change to how you organize maybe a new SCP or a new account, you can just do all of that through this built-in pipeline. It's an amazing tool for anyone who's having to manage multiple AWS accounts, and you can go to this URL to learn more. Another CLI that I use is actually something that I built for Lumigo based on a lot of things that I find frustrating that we don't have tools for that. It's called the Lumigo CLI. One of the things that I find quite useful is being able to just really quickly list all the functions I have in all of my regions and also see what's the last activity, when it was updated and so on. Just a very high-level summary in terms of what do we have in terms of functions. And also, I can analyze with a single command the rough estimated cost for all of my functions in all of the regions based on the invocation count and duration and so on, so that I can see roughly how much those functions are costing me. The key thing here I would say is that even though this is quite useful information, this is not the only thing you do in terms of the cost optimization, because in a serverless application, the cost for Lambda functions are usually a very, very small part of your actual overall cost on the AWS bill. API gateway, step functions, CloudWatch logs, they typically cost a lot more than Lambda themselves. This is just a useful guideline for you to see, okay, we've got functions that runs a lot, and also every execution is kind of expensive. So maybe there's something we can do, maybe by tuning the memory settings, because Lambda is charged in duration, but also your memory allocation. So that brings me to the next one. But before that, I'll talk about Lambda cold start, which is, again, single command to analyze the cold start time for your functions over the last certain amount of time. In terms of optimizing and finding the right memory settings you have for your function, there's a single command you can run to say, please tune my function against different memory settings, and then let me know, based on my preferred strategy, whether to optimize for cost, speed, or have some nice balance, what's the right memory setting I should use. And in this case, it's saying we should use 512. And if I want to visualize the results, I can see why. Because the cost is going to go up as we increase more memory, and the performance is going to get better. And based on the fact that I asked for a balanced profile, it's detected that, well, based on the memory settings that we tested, 512 is going to give the best balance between performance and cost. And if you use a lot of Kinesis streams or DB streams, oftentimes I also find it struggle to find out, okay, something is not working, where is the problem? Are the events just not happening on the stream, or is there something wrong with the function? So I've got a command that allows you to tell whatever is happening inside the stream, so they can see, okay, these are the events that's flowing into the stream, whether it's the DB streams or it's the Kinesis streams. Same goes to SQS queues and SNS topics. And if you like Lego, you use a lot of EventBridge, then you can also tell EventBridge bus or EventBridge rule as well. So if you want to just listen for everything that's happening on a bus, you can tell the bus itself. Or if you only care about what events are captured by this particular rule, you can just tell that rule. And then also, we do, when using DLQs, the next thing often it comes after having a DLQ is how do we replay those events from the DLQ back to the main thing. So there's also a command that allows you to replay DLQ events and publish them to either SNS, SQS, or Kinesis as a target. Also, switching between different profiles is also a pain as well. And once you have done your AWS configure and set up multiple profiles, there's a command also that allows you to easily and quickly switch between different profiles, different named profiles you have configured already. In total, there's like 15 or 20 different commands. Think of it as your Swiss Army knife for doing lots of small things that are usually frustrating or hard to do in AWS. So those two CLIs I use every day, and then there's also a bunch of different libraries that I often use as well. The first one is Docker Lambda from Michael Hart. This one, if you're using Server Framework or SAM and you're using Serverless Invoke Local or SAM Local Invoke, then you're probably using this by proxy already. So both frameworks use this Docker Lambda to allow you to run functions locally. But also, sometimes when you're building, say, using Go, for example, or you have dependencies that are native, and you want to make sure that you're building for the right environment, then this is a very useful tool for you to make sure that whatever you're building, those native binaries, they are going to work. They have, based on, so these are almost exact replica of the actual environment that you have for Lambda executions. And then there's also MIDI, which is a middleware engine for Node.js functions that runs on AWS Lambda, whereby you've got a bunch of useful built-in middlewares. For example, there's one for supporting cores, so that you always return the right headers and so on for cores. But also there's two built-in plugins, well, middlewares, for fetching and caching secrets from secrets manager and SSM parameter store. So when it comes to secret management, the golden rule that I always follow is that your secrets should never be in plain text in your environment variables. I see loads of organizations that care an awful lot about security do the right thing at the first step, whereby they will put those secrets, they will encrypt them with KMS, they'll put them inside secrets manager or in the SSM parameter store, but then before deployment, they will run, say, serverless deploy. At that point, during deployment time, they will fetch and decrypt the secret and bake them into the serverless YAML and deploy them so that at runtime, those secrets are in plain text in the environment variables. Now, if I'm an attacker and I manage to compromise your function by maybe compromising one of your dependencies, then hooray. Your environment variables is the first place I'm going to look for sensitive information that you don't want me to get hold of. And you may say, well, that's just not going to happen. No one's going to compromise NPM ecosystem, but it happens all the time. Sometimes the case of people getting access to NPM packages, publish rights to NPM packages, and other times it's something as simple as engineers being social engineered, whereby in this particular case, someone published a bunch of packages that has got a similar name to real popular NPM packages. So instead of cross-env, you have cross-env or cross_env. And the first thing this package is doing is scanning your environment variables and then harvest them by sending them to some endpoint the attacker has set up. So at that point, the attacker may find out about your database connection strings. If you put them into environment variables, they may find out about your API keys for different services and so on. So what should you do instead? Well, my personal preference is to have the function themselves fetch the parameters and configurations at runtime when it boots up during cold start, and then caches it. And every couple of minutes or so, it invalidates the cache, so that when we do want to rotate those keys and secrets and so on, we just need to update it in the source, and then the function, we just pick it up the next time it invalidates the cache. So you can either do it yourself, or if you're using the middleware, then it's something as simple as this, whereby we want to get those parameters from the service name, the access token, put into attribute called access token, and save it into the context object. So now, if the attacker wants to steal that, they will have to understand our code to know that, okay, I have to look for it in this object called context, as opposed to just blindly looking at what's inside your environment variables. If you want to use the SSM parameter store, another thing to keep in mind is that by default, there's a very low throughput limit of 40 ops per second with SSM parameter store. And nowadays, you could get a much higher throughput by going to the paid tier, where you start paying for SSM, but now you get, I think, a top throughput about 1,000 requests per second. So the reason why the original throughput is so low is because it's a free service, SSM, and of course, Amazon doesn't want everyone to start to abuse it like a database. Next one is another tool that I built with my previous company at the Zone, whereby we were writing a lot of Lambda functions in the Node.js. And we run into the issue of how do we make sure that we apply best logging practices and we capture correlation IDs and we forward them, even though our function is going to be talking to HTTP endpoints, talking to SNS, SQS, Kinesis, and Event Bridge, and so on. So we've got a bunch of different client wrappers for these different services. And we allow you to have basically a very simple way to declare using middlewares that captures correlation IDs, make sure that when you're logging anything, they're always included in the logs. And also, whenever you're sending event to, say, Event Bridge, those correlation IDs are automatically forwarded, and the function on the other end will be able to pick them up and include in the logs automatically without someone having to consciously remember to, right, I need to take out our correlation IDs from here, including every single log message, and every time I do the next thing, I've got to remember to forward them on. So the way it works is that we've got a bunch of middlewares, and the main one is this middleware that before it calls to handle a function, it's going to inspect the event, extract the correlation IDs based on where the event came from. So if the event came from an API gateway, then we know correlation IDs is going to be in the headers. If it's coming from SNS, then we know they are going to be inside the message attributes. And if it's inside Event Bridge, it's also going to be in, I think, message attributes or something like that. So we know where to expect the correlation IDs. We extract them, make it available so that whenever you're logging anything, they will also always be included. So in terms of how to make this work, all you have to do really is use our logger and to install this package, which is basically a standard wrapper that applies a bunch of other things as well, including capturing correlation IDs. So we've got a module that captures all the correlation IDs, and you can also add your own ones as well. So sometimes we find we want to capture the correlation ID as the initial HTTP request ID from the client, or maybe from API gateway. But then sometimes we also want to record things like that are useful, such as maybe the order ID, if you're talking about order processing. So you start to enrich your transaction with more and more information, so that it becomes easy for you to find related log messages. And once you have that, then anytime when you're logging anything, then they're always going to be included. So that your logs will look something a lot more like this, where you've got not just a message, but also a lot more information about the context in which something has, this action has happened. And of course, if you use our HTTP client as well as the SDK clients, then they also automatically forward those correlation IDs onwards as well. So as a very simple example, API gateway and Lambda, someone makes a request to HTTP, then we extract, then we take the request ID from API gateway, use it to initialize our correlation ID with, so that when you use the HTTP client, you automatically gets included as a header, so the function on the other end knows to expect that and extract that and then make it available in every single log message. I mean, you might say, that's great, really makes debugging a lot easier. However, now you're writing a lot more data to CloudWatch logs, and CloudWatch logs charges you something like 50 cents per gigabyte of data ingested, and 3 cents per gig per month for data archival as well. So now your cost can potentially just explode, especially when you consider that Lambda function, 120 meg, 1 million invocations, only going to cost you 40 cents instead of 50 cents. So here is a painful lesson quite a few of my clients have learned, is that don't enable debug logging in production. You want to make sure that you be logging at a much higher level, maybe error, maybe warning, whatever makes sense for you, but don't leave debug logging on. You're going to flood your logs, and you're going to pay for them, and most of the time, they're just going to be noise anyway. But then when something does happen, so many times you realize, wait a minute, we know how to fix this if we just had the debug logs available to us in the first place. So you can find a nice compromise there. So in that case, someone asked me a question in the workshop, then don't you have to then enable debug logging, redeploy all your services, all the functions on the whole chain, on the whole transaction, just to get enough debug logs in. So the nice compromise there is instead you will sample some percentage of the debug logs for invocations. So in this case, we can have a middleware that enables debug logging for 1% of invocations, and then afterwards roll it back to the previous log level that you have configured. And it can be something as simple as this, whereby before we call your handler function, we check, should we enable debug logging? If so, we enable it. And then afterwards, we roll back a decision, and also we will also log anytime your function errors. We capture the invocation event itself and make sure there's an error message that you can find and see the invocation event, so that you can then replay them locally to try to reproduce the error. In this case, we have a middleware that enables this sampling behavior. And again, if you're using just the standard package, the wrapper, then it also applies them by default using a percentage of sampling at one sample rate of 1%. Another important detail here is that when you've got a transaction like this, where you've got a workflow that involves many event sources and Lambda functions, you don't want to be sampling debug logs independently of each other, because you're then going to end up with 1% of debug logs here, 1% of debug logs there, but you never get the whole transaction. You never see the debug logs for one transaction. So this is where also what we do with a lot of these libraries is that we forward the decision to whether or not to enable debug logging at the first function, and then pass it on as a correlation ID, so that all the functions in the whole code chain will respect that decision, so that essentially you are enabling debug logging for 1% of transactions rather than invocations. So those are some of the libraries I think I use every day, but then there's also a bunch of different SAR applications or service application repositories. Essentially, I don't know if you ever use that, but essentially it's a place where someone like me or others can publish existing packaged up applications that include Lambda functions, API gateway, and other things, so that other people can just use it as a component rather than individual functions. One that I wrote myself and also a lot of people have used now is, well, when you've got Lambda functions, you also have a regional limit of 75 gig for code storage. And when you've got, you may think that's a lot, especially when you're dealing with functions that aren't that big themselves. But then when you've got teams that deploy all the time, constantly, then last time I was in a very small team, we were doing all serverless. We managed to rack up 20 gig of code storage within the first month of working on a new project. So this Lambda janitor just looks at the versions that are currently alive, and which the ones that are no longer referenced by an alias and not latest, and you just delete them for you so that you don't have to constantly go back and clean them up. And you deploy this once to your region, and you look after all the functions that you have in the region. There's also a number of guardrails that's built in to make sure that we always keep the last, I think, 3 versions so that you can always have something to roll back to if you need to quickly. Another one is from Alex Casaboni, which is the thing we saw earlier, where you can tune your function's memory setting by running against multiple memory settings to find the best one. And so you can use this yourself directly, or you can use the Lumigo CLI, which gives you a command line to use it as well. And then one I found quite useful a few times is this from Alexander. So whereby I've got this star app I can deploy, and then basically I can get SNS notifications whenever objects are dropped into S3 bucket. Another one that I do use all the time is every time a new function is created, by default it creates a new log group. And I want to make sure that if I want to make sure that all of my logs are going to, say, Datadog or Logzio or Logly, whatever, normally there's some overhead in terms of subscribing your log groups to something that ships the logs to Logly or Logzio or whatnot. So this star app just manages that for you. You deploy it once to your region, and then any log group you currently have in the region, as well as any ones you create in the future, will just be taken care of automatically without you having to remember to do that on every single project. And equally, if you're shipping your logs somewhere else already, you don't want to be paying for them in CloudWatch as well. So there's another app which all it does is just whenever you create a new log group that matches the sort of targeting prefix and whatnot, change the default retention from never expire to, say, whatever number of days that you configure. And the last one is quite useful for if you do a lot of work with step functions. So step functions introduce this ability for you to have like a callback pattern whereby potentially you have a workflow that allows you to send a message to SQS, and some other system is going to pick it up and process it, and I'm just going to wait. I'm going to pause my execution until the other system I say, yep, I'm done, and here's the result. So that pattern is quite useful for doing a lot of, so integrating a lot of the asynchronous processes into your step function workflow. However, for someone to report that something is done, they have to actually make a call to step functions API itself, which makes it harder for you to implement some of the manual integrations for workflow that involves, say, someone getting an email and clicking a button to approve or disapprove. So this project, this app from Ben Cahill is really useful. It gives you a way to create a callback URL, so that I can say, well, my step functions is going to get to the point. It's going to ask some person to say, OK, I want to approve this thing. And then that can be just targeting a callback URL. And that will call the step functions execution to continue. And that's all the different tools I want to talk about. All of these tools are open source. They're all free to use. And before I let you guys go, as far as they have your attention, you can reach out to me if you want help with service applications or just getting some advice on best practices and where service fits by going to my blog, theburningmonk.com, and also running a bunch of different workshops this year around Europe. And I'm going to be back here in Stockholm in May. We are going to run a 2-day workshop that covers everything from how to build basic applications with Lambda, API Gateway, Event Bridge, and so on, but also best practices around the CI/CD, security, how to do tracing, logging properly, and all of that. And for you guys here, there's also a special discount code as well, just for you guys. You can get 20% off the tickets. So I'm going to be back here in May, 14th and 15th. So yeah, with that, thank you guys very much for your time and your attention. The slides are already online. I'm going to tweet it on against the AWS Community Day hashtag soon. Thank you.